Earth, the blue planet, warm and hospitable for the past 11,000 years. But how much longer will that last? Imagine our world in the not-too-distant future. Temperatures may plummet. In parts of the northern hemisphere, the temperature drops to -9 degrees Fahrenheit. For the first time in 200 years, ice forms on the River Thames in London. Then the bottom falls out of the thermometer. At 13 degrees below, public transportation fails. As 10 feet of snow falls, roads become impassable for all but snowmobiles. Those caught outside are freezing to death. Buildings collapse under the weight of snow and ice. The infrastructure crumbles, and society struggles to survive. Could this be a vision of our future? Today, our peaceful climate bathes fertile lands in warm weather, allowing civilization to flourish. But it hasn't always been like that. The Earth follows a cycle of freezing ice ages, followed by warmer interglacial periods. Recent centuries have been kind to humankind. The last 10,000 years have seen just one major cooling. But this could all change. Some scientists now suspect that the stable climate of the past was not so stable after all. They believe the Earth can suddenly plunge into micro-ice ages or giant freezes, lasting as long as 1,000 years. With devastating blizzards crippling our cities and destroying crops. Terrifyingly, this new freezing climate could hit us far sooner than we think, with little or no warning. This may sound like scaremongering, but the people of Montreal have already had a tiny taste of just how deadly a giant freeze can be. January 5th, 1998. Temperatures suddenly drop to 15 degrees, and a violent ice storm strikes, coating the city in freezing rain. This thriving metropolis becomes a frozen, barren wasteland. Living through this icy disaster is journalist Alan Hustak. Hustak returns home from work as a power outage strikes the city, something all too familiar to the residents of snowy Montreal.
The first evening was kind of like a carnival. You lit the fireplace and lit the candles and knew that tomorrow everything will get back to normal, and then of course tomorrow it didn't.
It's very far from normal and getting far worse. Over the next 5 days, a massive storm dumps 4 inches of freezing rain on Montreal. It falls as water, but freezes on impact to build up layers of solid ice. Its weight crumples electrical towers. The city buckles. Up to 1.4 million homes have no power. The ice storm exposes the Achilles heel of modern cities, our total reliance on technology.
We are so used in a large North American city of 3.5 million to having your television, having your microwave, having your computers, and it was gone in an instant. It was gone in an instant.
Today's dependence on electricity makes us even more vulnerable to climate change than were our ancestors of hundreds of years ago.
Try it yourself. Shut the power off in your house and try and function without any of the things that you take for granted.
Hoostak City becomes unrecognizable.
This street was absolutely a glistening landscape of ice. The streets were caked with ice, the building was caked in ice, the roofs were caked in ice, the green mansard roof was all caked in ice. It looked like a giant wedding cake. And the monument over here to Lord Nelson was like a giant popsicle in the middle of the square.
However, amid all the destruction, Hoostak holds an ace up his sleeve. His apartment has a wood-burning fireplace that's unaffected by the power cuts. But after 4 days of constant use, he runs out of wood.
You couldn't buy wood, and we had nothing to burn. So I had to go back to my apartment, and we burned the legs of the dining room table to keep warm that night. And of course, it's at this point where you begin to wonder how much longer you're going to be able to continue.
It's 5 icy days and freezing nights before power finally returns to Montreal. The damage totals more than $2.5 billion. 30 people die. It destroys over 3,000 electricity towers and all but one line or grid feeding the city. Hoostak believes the situation could have been a lot worse.
We were left with one grid. And had that grid gone down, I mean, the city would have had to have been evacuated because we would have been without electricity for 2 or 3 months.
It's a scary lesson for everyone living in a modern city, thinking ourselves safe in the warmth of our homes. The ice storm that made Montreal citizens burn their furniture just to stay alive lasts barely a week. Imagine what would happen in a giant freeze, one that lasts for years. Picture your own city covered in ice, not just for days, but for weeks, maybe months, or even a lifetime. Is this a true vision of the future? Scientists are piecing together a clearer picture of how our climate has behaved over the last 160,000 years, and it's not a comforting image. To understand what might cause a big freeze, we must look at the bigger picture and discover what drives our planet in and out of ice ages over millions and millions of years. Normally, our planet swings rhythmically between cold ice ages and warmer periods that scientists call interglacials. It's the Earth's rotation around the Sun that causes these swings in and out of ice ages. Earth's orbit is far from simple. It varies in a number of complex ways, most importantly, in the shape of the orbit. It's not always a perfect circle. Through a cycle lasting about 100,000 years, the orbit goes from being almost round to being stretched into an oval shape and back to almost round again. In the more elliptical orbit, we travel 3 million miles further away from the Sun. Less sunlight reaches the Earth, and an ice age is born. But this vast astronomical cycle causes large temperature swings that are slow and predictable. Today we live in a warm interglacial period. Eventually, Earth's orbit will alter once again, and a new ice age will freeze us, but not for another 10 to 20,000 years. But if you think you're safe from the cold, think again. New research suggests that our climate is far less predictable and far more unstable than we ever thought possible. This new vision was revealed by geologist Richard Alley.
The climate sometimes jumps out and surprises us. Sometimes it tips over, sometimes it flips a switch, and it's not always nice and smooth and easy to predict.
Alley's passion is frozen H2O. He is one of the world's leading experts on ice. He studies the climate by collecting deep samples of ice, called ice cores. Ice stores a treasure trove of data about the climate of centuries past. Every year as snow falls, it forms a layer of ice on the surface of ice sheets and glaciers. Each annual layer of ice remains on the surface until it is covered up by the following year's snowfall. Over thousands of years, these layers build up one on top of the other. The deeper the layer, the older the ice. To access this ancient ice, scientists send a hollow drill deep into its frozen heart to pull out a solid column, an ice core. Drilling deeper and deeper into the ice exposes layers that first fell as snow thousands of years ago. The ice and chemicals it traps have remained untouched ever since. Studying ice cores is a little like having a time machine. By comparing the thickness of each layer, Ali deduces what happened to the climate year by year. He made his most amazing discovery in Greenland when he drilled out a 2-mile-deep ice core.
We took a 2-mile-long ice cores and we got over 100,000 years of the history of the climate, and it was phenomenal.
The ice history uncovered by Ali reveals that the major climatic swings between warm interglacial periods and ice ages are only part of the story.
The climate usually sort of changes nicely and smoothly and gradually, and sometimes it just changes. And years, a single year, there's huge climate changes.
These huge and sudden swings tear apart previously held beliefs that our climate is in any way predictable.
We stood there in a snow trench in Greenland and looked at this record coming out of the ice cores, and the world changed. And that was just phenomenal, just extraordinary discovery.
The evidence shows our climate swinging wildly between extremes, with changes happening not only within the ice ages, but also within the interglacial periods scientists once thought were stable. The bad news is, these swings are big, really big. They can last over 1,000 years. Even worse, they act rapidly, striking and totally changing our climate within a decade.
The size of many of them was sort of half the distance between an ice age and today. In central Greenland, 18 degrees Fahrenheit, 20-some degrees Fahrenheit for the biggest ones. So these are big changes in something like 10 years.
Ali's research shows that the climate can change suddenly and in a very short time. The warm existence enjoyed by most of us in the world could disappear should our weather turn hostile. But even more worryingly, this crazily swinging climate appears to be a normal state of affairs. It is the boring, stable weather that we've enjoyed for the past 10,000 years that is, in fact, a freak of nature.
We've seen this history of boing, 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 boring. And that boing, boing, boing sort of looks like what's normal, that we should be used to crazy climates, and this boring that we have is sort of as good as it gets.
If Ali is right, another big freeze could be on the way. A freeze that could cripple our cities, destroy our crops, and change the socio-political face of the planet. But how and when might it strike? Scientists are racing to some of the most extreme places on Earth to identify what it is that causes such dramatic climate change. In a supreme irony, it appears that it may be triggered not by cold, but by a combination of fire, brimstone, and extreme heat. The Earth is currently enjoying a period of warm, stable climate. But it hasn't always been this way. Scientists are discovering that the Earth's true climate swings rapidly between warm spells and freezes. And these swings can be sudden and devastating. Scientists have been trying to discover what causes these sudden swings. They have identified one possible culprit: volcanoes. Ironically, this clue came from deep in the ice. Lonnie Thompson is a glaciologist who specializes in plotting the history of our climate by studying ice cores.
Ice is like a time machine in that it records the history of the past, and the deeper you go, the further back in time you go. You can look at the 20th century, but you can look at thousands and thousands of years of history.
Thompson has collected cores from all over the world. His impressive collection is kept at -30 degrees in his cold room in Ohio.
These cores come from the South Pole in Antarctica. These are Bonar Churchill from southeast of Alaska, Kilimanjaro from Africa, Dai 3 in southern Greenland, a Huascarán from the Andes of South America. These are cores that come from around the periphery of the Greenland ice sheet.
What makes the ice cores so useful to climatologists like Thompson is that they absorb and perfectly preserve chemicals and particles in the atmosphere, allowing scientists to record ancient atmospheric composition and discover what natural phenomena occurred at the time.
You can see when we put lead in gasoline. You can see when we pass legislation to take the lead out of the gasoline. So they're a very good recorder of anything that's in the atmosphere.
They can preserve sand and dust from years of drought.
The beauty of the ice is that this dust is preserved as it fell. It represents a drought that occurred in Africa 4,200 years ago.
They also preserve dark layers of volcanic ash. Dotted around Thompson's cores are the records of volcanic eruptions.
So if you look at these, you can see the eruption of Huayna Patina from February 17th, 1600 AD.
By measuring the concentrations of atmospheric gases and the radioactive isotopes trapped within a layer of ice immediately after the layer of volcanic ash, Thompson is able to determine the climate dating to that year. He discovers that after major eruptions, the temperature drops. Somehow, the big eruptions are triggering sudden coolings. Erupting volcanoes fire vast quantities of ash into the atmosphere. This ash is made of such tiny particles of rock that it floats on the wind. Traveling around the globe, it forms a blanket high in the sky, cutting down the sunlight and cooling the planet below. The ash then falls to Earth to be trapped in the ice cores. By dating each layer of ash in the core, Thompson is able to build up a picture of what happened to the climate after each eruption.
1815, the eruption of Tambora. Indonesia volcano led to the year without a summer.
In Europe, the summer temperatures were 5 degrees lower than normal. Wheat crops failed, and thousands of people died of famine. Even the USA was affected.
Here in Ohio, we actually had snow in July during that summer. No crops were produced. So these volcanoes can have a very immediate impact on the climate.
Scientific analysis of the ice cores reveals that the volcanoes affect our planet's temperature in several ways, because volcanic ash from eruptions is not the only cause of a sudden freeze. Volcanoes have another weapon. A gas that can actually reflect the energy from our only heat source, sunlight, back into space. Along with the ash cloud, volcanoes pump a cocktail of gases high into the atmosphere. Volcanologist Dave Schneider analyzes these gases by flying over the craters of active volcanoes. His laboratory is the state of Alaska, the most volcanically active area of the United States. Today, Schneider is flying to Mount Spur, an active volcano that has been smoldering over the last year. He will fly directly over Mount Spur's crater and through its gas cloud.
Security 357, where are you going? We're going to Mount Spur. Runway 6 left, about 3.5 miles in trail. They have a 60 knot overtake.
The horizon is littered with volcanoes. Schneider knows them all.
There's a lot of beautiful volcanoes in Alaska, and you know, one is more interesting than the next, and it's hard to come up with. It's like asking which of your kids do you like the best. After an hour, they arrive at the simmering volcano. And right now we're just flying over the caldera rim from an eruption, you know, tens of thousands of years ago, formed a large caldera at the summit. And then the new summit here is a volcanic dome that has grown in that crater afterwards. In his airborne laboratory, Schneider gets down to work. What was our altitude at right there, Ron?
82 right now. You want a little bit lower?
Schneider is analyzing the volcanic cloud for clues as to how it alters the weather. It doesn't take long for him to find the volcano's secret weapon, the gas sulfur dioxide. There's a faint odor of sulfur dioxide that you can smell as we fly by, just pulling it in from the air vents. That's exactly what we're trying to measure here. When it comes to global cooling, sulfur dioxide is the most damaging of all the volcano's gases. Big eruptions blast sulfur dioxide high into the upper atmosphere, where it reacts with water vapor to form droplets of sulfuric acid.
Sulfuric acid droplets are very shiny, much like this mirror, and they reflect the incoming sunlight back up into space, which would have the net effect of cooling the Earth.
Imagine billions of tiny mirrors floating above our planet, reflecting the sun's light back into space. Far less sunshine reaches our planet, and temperatures drop. The effect of sulfur dioxide is so powerful that even non-explosive eruptions, producing little or no volcanic ash, can drastically affect climate. In 1783, Mount Laki in Iceland started to ooze sulfur-rich lava from cracks in the Earth's surface. It produced no ash, but lots of sulfur dioxide. This caused the average temperatures in the eastern US to fall over 9 degrees the following year. But are these temperature hiccups triggered by volcanoes big enough to seriously affect life on Earth? Some scientists suggest they are. In fact, a volcanic eruption almost 1,500 years ago changed the weather so radically that it may have altered the course of human history. Historian David Keyes thinks a colossal eruption in 535 AD entombed our planet within a cloud of volcanic gas and dust.
A lot of the accounts from the period actually say that the sun shone like the moon for a year.
The drop in global temperature had huge and surprising side effects on societies around the world. Old empires were destroyed and new ones flourished. The world we live in today emerged out of this global chaos.
It was a catastrophe and hugely changed the demography and the society of large swathes of Africa, the Middle East and Europe, and as a direct result in that, changed history.
The sudden drop in temperature triggered by volcanic eruptions produces complex effects. It wrecks the delicate balance of our daily weather patterns. A climate change of just a few degrees could send weather tumbling out of control in many parts of the world.
Massive storms, droughts, floods, that sort of thing. Really, it's these extreme weather events, which are the business end, if you like, of climatic problems.
Just imagine if every year our cities are pummeled by hurricanes, countless floods, and by tornado after tornado. Triggering such extreme weather events could kickstart an unstoppable chain reaction that leads to global catastrophe. It's a bit like a set of toppling dominoes. The first domino to fall would be climate change, which could cause more violent weather in parts of the globe. This weather chaos causes crops to fail, which leads to famine and starvation, and then disease. And once dominoes start tumbling, nothing can stop them. Next, comes civil unrest, the collapse of a society's infrastructure, and eventually, total anarchy. But there's a twist in the climate change tale. It could affect different countries in different ways. Some scientists believe that the most advanced societies will feel the effects the hardest. They argue the more developed the society, the more there is to be broken.
The higher you go, the further you can fall. So if you have a society that's very, very complex and very sophisticated, it's very, very vulnerable if things go wrong.
Less advanced cultures, although still affected, don't have so far to fall. They could suddenly find themselves able to compete with previously dominant cultures on a more equal basis. The result could be a realignment of political and military power, a free-for-all that often leads to war.
It's a bit like a sort of grand game of geopolitical musical chairs, where suddenly you get climatic problems and their repercussions, and everybody has to swap round a bit.
Keyes believes that it doesn't require a huge climatic event to trigger one of these reshuffles. Even small changes could have an effect.
Climate change has the effect of resynchronizing history. And it's done that in the past, and I've no doubt it will do it in the future.
Volcanoes can cause devastating cooling, but the effect only lasts for a few years. Imagine a giant freeze that lasts for 1,000 years with the power to wipe out whole species. Such a dramatic freeze happened 13,000 years ago. Now, some scientists are worried that parts of the planet may face another cooling in the near future. History has shown that even small changes in the climate, sometimes of no more than a few degrees for a few years, can change the course of civilization and push societies to the brink of disaster. But what would happen if the change in the climate was long-term and much more severe? Could it have the power to wipe out a whole species? The answer may lie deep below ground in the Great Saltpeter Cave in Rockcastle County, Kentucky. Anthropologist Kenneth B. Tankersley studies sudden climate change by examining fossils. His research may shed light on the power of the weather.
What we find here, I think, can help us adapt to future climatic change. Literally, our survival may be in the sediments within this cave.
Tankersley leads a team deep underground, hunting for evidence of a sudden climate change that took place at the end of the Pleistocene period, 13,500 years ago. This cave is packed with the remains of animals that died thousands of years ago and were washed underground.
Caves are environmental magnets. They collect plant and animal remains primarily because caves function as Mother Nature's sewers.
The constant temperature and humidity in the caves preserve animal bones in sediment layers, one on top of another, perfectly filed in chronological order.
We go deeper and deeper in the cave. We're going further and further back in time. I've often thought that if I walked just a little bit faster, I could actually catch up with the people and the animals that lived during the last ice age.
Tankersley's team worked their way deep into the cave system. They're searching for fossils. Accumulations of fossil bones and plant material in caves are called middens. They are a good indicator of how changeable our climate has been in the past. Tankersley uses a simple hand-powered coring tool. The deeper they drive it into the ground, the older the layer of fossils they extract. He finds a bone bed a layer littered with fossils of creatures that are now extinct.
Going back, the reason we have a bone bed is because the environment's going under rapid, profound global climatic change. Let's see what we have in here.
Tankersley's layer of fossils dates to the end of the Pleistocene era, a time of dramatic climate change. He finds the remains of strange and ancient creatures, all of which have vanished from the face of the Earth.
Beautiful preservation. Excellent. Looks like it was probably from the heather vole, the giant snapping turtle, a piece of pygmy shrew, a phalange, or toe bone, if you will, of Platygonus compressus.
Platygonus compressus is a kind of giant pig. It's one of a group of creatures hardest hit by sudden climate change, the megamammals.
Megamammals are literally giant beasts that lived during the last ice age. Imagine for a moment a beaver that was the size of a black bear, or a ground sloth that was the size of a tree.
Tankersley believes many of the megamammals died at the end of the Pleistocene as the climate changed. It's uncertain why they disappeared, but Tankersley thinks sudden climate change played a role in wiping them off the face of the planet.
More than 30 different types of megamammals disappeared in a very short period of time.
The megamammals had very slow reproductive rates. It could be that the lengthy period between generations meant they were slower to adapt to change.
The climate changed rapidly and profoundly and globally, so fast that the megamammals did not have a chance.
Tankersley's research shows that sudden climate change can affect the survival of a species. What would it mean to us if the weather suddenly changed? A drop of a few degrees can cause crops like corn, rice, and wheat to fail, leading to global famine. Tankersley fears that humanity may stand little chance of survival if a massive freeze strikes.
Now, if we were to have another ice age, what we need for our own survival, if we were to land, would be tied up in glacial ice. The amount of areas that would be inhabitable, the amount of areas where we could produce food would be greatly reduced.
Could humanity be living on borrowed time? Could we too be wiped off the face of the planet? Understanding what triggers these climate swings may be our only chance of survival. But so far, the news is not good. It appears that we could be the ones who set off the next major freeze. Earth is currently in an interglacial period, one that has had an unusually stable climate, allowing civilization to flourish. But it turns out that this stable weather we have enjoyed is in fact a freak of nature, and sudden swings between cold and warm are the norm. And worryingly, one of these sudden coolings might strike sooner than you think. Scientists are keen to discover what triggers rapid and sustained climate change. Volcanoes can cause short-term cooling, but what about giant freezes?
If volcanoes could get organized, they could rule the world. But they don't seem capable of triggering ice ages. There's no way for an Alaskan volcano to tell an Indonesian volcano that it's time to erupt.
The cause of giant freezes may lie deep within our oceans. Temperature plays an important role in the movement of ocean currents. Warm water is less dense than cold water, so it tends to rise. Conversely, cold water is more dense, so it tends to sink. The seas at the equator receive more sunlight than those at the poles. So water here warms up and rises and moves toward the colder polar water. This movement is called the Great Ocean Conveyor. Once the warm water arrives at the poles, it cools and then sinks and is forced back to the equator along the ocean floor. The movement of warm water carries with it warm air. In the North Atlantic, that air movement is called the Gulf Stream. It carries the heat equivalent of the output of 1 million power stations. It's the main reason why England stays relatively warm, while at the same latitude, Canada has ice fields. The movement of warm water and air not only spreads warmth around the world, it also helps stabilize weather patterns. This stability helps civilization to flourish and sees our population soar from a mere 4 million to over 6 billion people today. But the ocean currents have not always flowed so reliably. If the function of the global conveyor water current is to keep the climate stable, how could it set off a freeze? The theory says that if the conveyor stops, then the distribution of warm water and warm air also stops, and this could lead to climate change. But what on earth would be powerful enough to stop the conveyor? One clue may come from the last big freeze to hit the planet. As our planet exits the last ice age around 13,000 years ago, temperatures start to rise. This causes the North American ice sheet to melt, and a vast lake of fresh water is trapped where Hudson Bay lies today. This lake is dammed by mountains of ice. But in one dramatic event, these dams burst. 2,500 trillion gallons of fresh water pour into the North Atlantic. That's about 450 times the volume that passes over Niagara Falls every day. This immense influx of fresh water drastically decreases the salinity of the North Atlantic. This wouldn't matter, apart from one vital fact. Fresh water is less dense than salt water. It refuses to sink. These density changes mean that the great ocean conveyor starts to slow down, and warm air stops circulating. Weather patterns are affected, and temperatures drop. Richard Alley's ice core records show dramatic swings in climate all over the world.
It affected probably the northern hemisphere almost instantly, and the southern hemisphere within 100 years or so.
This freeze is known as the Younger Dryas. Ice core records show that it chilled our planet for more than 1,000 years. This was the last big freeze to strike our world. But why worry? This happened over 10,000 years ago. Well, today, it might be happening again. Something is affecting the natural balance of our planet. Something that could bring our stable weather to an abrupt end sooner than we or scientists thought. Global warming. If you think this means longer summers and pleasant winters, you're going to be very disappointed. Global warming is throwing our fragile weather into disarray, and nobody knows what the consequences will be.
The Earth's climate is a little bit like a drunken human being. If you leave it alone, it just sits there. And when you force it to move, rather than going smoothly, it staggers on its way.
It is not known if our planet will keep the stable, pleasant weather we have enjoyed for the last 10,000 years. But some scientists worry that rising global temperatures might be upsetting our delicate climate system more than we realize. They suspect that global warming might actually push us staggering into a new freeze. As the temperature rises, the melting Arctic ice and glaciers and ice sheets will pour cold, fresh water into the oceans. This could slow down the ocean conveyor and cause a drop in temperature in parts of the globe.
There's this slight worry that we are warming the world and that this will cause melting in Greenland. And if too much fresh water gets into the North Atlantic, global warming could cause freezing around the North Atlantic. so that some people would actually see a rather startling cooling from global warming.
It may sound unlikely, but scientists are currently carrying out studies to learn just how big an impact global warming might have on global freezing. Many, like climatologist Don Perovich, have traveled to Barrow, Alaska, the most northerly settlement in the U.S., to study global warming.
If there is global warming, this will be where you'll see it first. This will be where the signal's the largest. So naturally, that's where you want to look.
Perovich studies the impact of global warming on ice cover. His findings are disturbing.
Roughly speaking, the Arctic sea ice covers around the size of the United States. And if you look back over the past 30 years, each decade it's lost an equivalent size of New Hampshire and Colorado.
Some scientists believe that Arctic sea ice in summer may disappear completely within 5 decades. This devastating warming is thought to be caused by emissions of greenhouse gases into the atmosphere from burning fossil fuels. To help understand the effects of this warming, Perovich travels out onto the Arctic sea ice. He drills a hole through the ice to measure its thickness. Perovich's studies reveal that the Arctic ice is not just shrinking, it's also thinning.
We see the areas changing a few % per decade, and you might say, well, so what? Well, there's another dimension to the ice cover, and that's its thickness, and we really want to know how that's changing.
In the 1960s, the Arctic sea ice was on average more than 10 feet thick. Today, it's under 6.
And that's a 40% decrease in the overall average thickness. Perennial ice cover could be gone in 50 years. What that means is that in the summer there'd be no Arctic sea ice. And that's something that hasn't occurred in hundreds, if not thousands of years.
This loss of Arctic sea ice could lead to disaster. The ice is acting as a plug, stopping glaciers of freshwater ice from simply pouring into oceans. When sea ice disappears, these freshwater glaciers surge into the oceans unchecked. This decreases the salinity of the oceans and disrupts the smooth running of the Great Ocean Conveyor. Every year, glaciers the size of Rhode Island crash into the sea, adding more than 300 trillion gallons of fresh water. As more and more ice melts, just as it did around 13,000 years ago, it could threaten to trigger another big freeze. But at present, nobody knows if or when it will happen, or how severe it could be. But if it's even a fraction as severe as the Younger Dryas freeze, it could threaten life as we know it. The Earth may be facing a sudden cooling. Around 13,000 years ago, at the end of the last ice age, the planet rapidly warmed. It's believed that the ocean conveyor shut down, triggering a sudden freeze. Today, global warming is melting glaciers and ice sheets, and thereby freshening our oceans. And scientists are worried that this climate change could trigger another giant freeze. Oceanographer Neil Bogue has come to the Greenland coast to study the North Atlantic. He believes that right now, global warming may be shutting down the ocean conveyor, endangering our planet.
I think there's evidence to indicate that it's slowing down. Whether it will continue or whether there will be a reversal, these are the things that our research hopes to answer.
Bogue and his team measure the salinity and temperature of the Labrador Sea, a crucial part of the icy North Atlantic. These measurements tell him how much icy cold water is sinking and how quickly. It's an excellent indicator of the Great Ocean Conveyor's state of health.
The research we're doing here in the Labrador Sea is crucial to making much better predictions about the effects of the changes in the ocean conveyor belt on climate.
They're here to launch a sea glider. This high-tech torpedo measures the salinity and temperature of the Labrador Sea. Bogue hopes this new technology will allow them to finally answer the question, is the Great Ocean Conveyor shutting down? The scientists are at the mercy of the weather, which sometimes means working at night. They must launch the sea glider in deep water, which means operating 40 miles from the coast. They launch the glider and watch it disappear into the pitch-black North Atlantic. Their work reveals something about this part of the conveyor that we didn't want to hear.
Deep water is not being formed as fast. So the thing that drives the ocean conveyor belt, the driving force, is actually not present as strongly as it has been in the past.
Bogue is concerned that changes in the Great Ocean Conveyor could take place in a relatively short period of time.
Significant changes could take place in timescales of decades, tens of years, 10, 20, 30 years, certainly within a scale of a normal human lifetime.
Bogue is not the only one concerned. Researchers from the National Oceanography Center in Southampton, England, have been studying water flow in the Atlantic over the last 50 years. Their studies show that until 2004, the ocean conveyor stayed constant, but then it suddenly changed and slowed down. They too believe that ice melting from global warming could shut down the ocean conveyor. Their frightening prediction is that in the next 20 years, the temperatures of Britain and continental Europe will become more like parts of Canada. Temperatures could drop up to 10 degrees. In winter, it could fall to more than 30 degrees below freezing. If they are right, this could mean catastrophe. Crops will fail. People will starve. And this would be just the start. As temperatures plunge below zero, cities like London, England are thrown into chaos. There are power outages. Drinking water supplies freeze. Soon public transportation fails. Cars won't start. Roads become covered with snow and ice. Only people with snowmobiles can get around. Because the human body cannot survive in temperatures below -30 without specialist survival clothes, anyone caught outside freezes to death. Roads and rivers become impassable. The city slowly becomes entombed in snow and ice. Buildings start to crumble and collapse under the weight. Eventually, the city dies, and society is pushed to the edge of oblivion. It's not a very optimistic vision of the future. So just how likely is it that such a freeze will strike? We may experience a short-term cooling brought about by volcanic eruptions, which could trigger wars and famine. But it could be something much bigger. Some scientists now believe there is a 50% chance that the ocean conveyor will shut down in the next 100 years. This may bring about radical changes in global weather patterns. There could be violent storms and flooding. There will also be some dramatic cooling in parts of North America, Britain, and Europe.
The folks right around the North Atlantic, it would be really cold in the winter, and you would probably see the British buying a lot of snowplows.
Chances are our climate will be far more violent than our peaceful one today. It will no longer be stable and could catapult the planet into a big freeze. A freeze that may change the world as we know it forever.